Day 2 of 1B, and this is going to be 1B3, and we're just going to continue the transformations. And by now, hopefully today, you have this down pretty well. This is our general transformation form. We're again, just a quick recap. We're going to do our stretching and compressing, where we have the horizontal and the vertical components of that. Then we're going to do our reflecting, which is basically plus or minus what's happening to those horizontal and vertical components. And then our translations, right and left and up and down. So let's go ahead and take a look at some of the examples that we're going to be doing. So here we have a function, and we're going to first identify the parent function. And what we have here is an even-powered parent function of basically x squared. So the parent function would just be x squared. And the generic, therefore, would be like this. It's -3, and it's going to be x minus 5. Oops, g. Let's call this g. Sorry. And x minus 5 plus 2. Okay? So that would be our generic function. So let's go ahead and take a look at this table right here. And I have the horizontal and vertical impacts of whether it's stretch or shrinking, reflections, and shifts. Okay? So first thing we're going to do is that we're going to look at this and we're going to realize, hey, we have a vertical stretch of a factor of 3. Okay, so we're going to put that in there. And our horizontal stretching factor is not there, so that's all we're really going to have. We do have a reflection across the x-axis, so we're going to have that, and it's going to be reflected across the x. So that's going to be across the x. I could put that right here, okay? And then, of course, we have our translations. We have a shift to the right 5, okay? And we're going up 2. That's pretty much it. And I'm not going to always provide these tables for you. You would just have to be able to list them out, and you can even list them out as 1, we have a vertical stretch by factor of 3, 2, we have a reflection across the x-axis, and 3, we have a translation right 5 up 2. So here we have in basically a verbal description of what's happening, we want to write the generic function. Well, we could just get right into it. We have a stretch factor of 6, so that would be like our A. We're going to go right 3 and up 7. So I could do like 6f of x minus 3, and we're going to go up 7. And that's all we're looking for. Don't overcomplicate this. So we have a little bit more 1. That's a little bit more complicated. And we're going to have a vertical stretch of factor of 20. So I'm going to write 20 times, I'm going to call this h of x, all right? And I have a horizontal stretch factor of 5. This is where people make the mistakes. This should be a good parentheses right here. I'm going to have 1 over 5. And then we're moving right 6. And then we're either going up or down, and we're going down 7. Now, I can rewrite this, and I would encourage y'all to do so. 20h and 1/5 x. You're just distributing the 1/5 is all you're doing. And there's my final answer. Okay? Alrighty, so these were just 3 quick examples. We're going to do a little bit more with these. We're going to start translating points and then graphs. Alrighty, I just heard a cat knock over a glass, so I'll go check that out.